Mathematica and the Raspberry Pi. 8-level raised cosine signaling. Most digital communication systems use binary signals where one bit is encoded into one of two levels. Nyquist channels can increase the effective bitrate by supporting amplitude modulation to encode more bits per symbol period. 2 bits requires 4 amplitudes, 3 bits require 8 amplitudes, and so on. This is possible because there is an instant when the Nyquist channels have 0 inter-symbol interference. Consequently, each symbol amplitude can be uniquely distinguished. This, however, requires very precise timing and a high signal-to-noise ratio. We start by clearing and defining the system variables. Then we can define and plot the raised cosine pulse. Random 3-bit data can be encoded into one symbol with one of 8 possible amplitudes. Removing the semicolon from the list plot will let us see the results of this. The raised cosine pulse is then multiplied by the data amplitude and formed into a data stream by using the sum command. Notice that the intersection of the waveform in the plot and the sampling instant coincides exactly with one of the 8 amplitude levels. We can notice that here, 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 and so on. This requires precise timing to get those exact values. To view the data stream in the time domain, rather than as a string of samples, we need to add a timestamp to each sample and then replot. And there it is. To make an eye diagram, we need to transform a single symbol sampling period into its time equivalent. And that looks like this. Notice that on the horizontal axis we have the sample number, and the vertical axis we have the time, corresponding to the interval between adjacent 0 crossings of the raised cosine pulse. We can then slice the transmitted signal into the individual symbol periods and overlay the result. And that gives us the eye diagram. Notice at the instant when the intersymbol interference drops to 0, each of the 8 amplitudes are uniquely distinguishable. However, if the timing is slightly off, the eye closes. And if we add a small amount of noise, the eye can also close.